Hello and welcome to another video on limits. In this video, we are going to talk about precise definition of limits. So far we did so much about limit. We started with the preliminary definition of limit, and then we learned about different techniques for computing limits. Now we are going to wrap up this chapter or this concept with the formal definition of limit. Okay, and it's also known as the precise definition of limits. Also, sometimes it's known as epsilon delta definition of limits. Now, this limit, it says here's the definition. So let f of x be a function defined for all x on an open interval that contains a, except possibly at a itself. Then we say that limit as x approaches a of f of x equals L if for every epsilon greater than 0 or for every positive number epsilon, there exists a positive number delta such that this holds. Okay, now this is same concept that we did with the preliminary definition. So what this definition does is it just formalizes the notion of closeness that we discussed with the preliminary definition of limit. So if you look at this graph here, so we can write this as so limit as x approaches a of f of x equals L. So when x approaches a here, okay, so when x approaches a from both direction, the function is approaching to this point here, which is L. So the limiting value of the limit for the function is L. Now, what does this formal definition say? It says that if we have some threshold, or if you give me a distance on the y-axis from L. So for example, if you give me a distance of epsilon, let's say this is epsilon here, okay? And then this is epsilon here. So you gave me some distance. So you tell me that the function should be within that distance of epsilon, or when function is coming closer and closer, okay, so when it is coming closer and closer to L, and we say that, okay, so the distance or the threshold for the function is epsilon, then what we will be able to do is for every epsilon that you give me, no matter what that epsilon is, it's a positive number, very small, tiny number. But for every epsilon that you give me, or for every threshold that you gave me on the y-axis, I will be able to find the threshold on the x-axis. Okay, so for example, here. So if you give me that threshold on y-axis, or the distance on y-axis, then I will be able to give you the distance on x-axis. So this one, this number here is the delta. Okay, so it just means, so no matter how close we make that, okay, no matter how close we move this value of the function on the y-axis, or no matter how close we go over there, we should always be able to find a distance or the positive number or the threshold for a on the x-axis. Okay, so if that happens, then we say the limit exists. Okay, so it's not that difficult. It looks very technical and more mathematical, but it just formalizes the concept that we talk about. So we say that when x is very, very close to a, the function is very, very close to L, and that's when we say limit as x approaches a of f of x equals L. And it's exactly the same thing that we are saying it more in more mathematical way. We are saying that if someone gives us this small distance of f of x from L, okay, so which is f of x minus L. So this is, if this distance is less than epsilon, then I'll be able to find the distance between x and a, which is less than delta. So if we change epsilon, then we get a different delta. So if we make epsilon smaller and smaller, our delta gets smaller and smaller. So that's what it says. Okay, so let's go ahead and look at an example here. So this is given figure shows the graph of a linear function f with limit as x approaches 4 f of x equals 5. So when x approaches 4 here, okay, so when x approaches 4, the limit is 5. So it's right here. Okay. Then for each value of epsilon greater than 0, determine the value of delta satisfying this statement here, this statement. Okay. Whenever x minus 4 is less than delta, the absolute value of x minus 4 is less than delta. So it's exactly the same definition that we have. So it says if f of x, the absolute value of f of x minus 5 is less than epsilon, okay, then we have this x minus 4, the absolute value of x minus 4 is less than delta, okay, and it has to be greater than 0 because this is a positive number. It's not 0. That means x cannot be equal to 4. Okay, it's a limiting value. So we are approaching to 4. Now, if epsilon is 1, then we are asked to find what is the corresponding delta. So if epsilon is 1, so let's say here's our number 5. So if epsilon is 1, then I can go 1 unit above that 5 and 1 unit below 5. So this is epsilon, which is 1. Okay, so this is epsilon, which is 1. Now, so for that epsilon, what is our delta? Or for that threshold on y-axis, what is our threshold, or what is the distance on the x-axis, the distance between a and x? Okay, so if we just draw that graph, if we go to that graph, and then if we come down here, so you do the same thing, you go over here, and then we come down here. Now, if this is my epsilon, then my corresponding delta is right here. So this is the delta, or this one. So which is 2. So if epsilon is 1, then delta equals 2 for this function. Now let's go ahead and change the epsilon. Let's make the epsilon smaller than 1. Okay, so the part 2 of that question says, okay, what happens if epsilon is 1/2? So let's check that. So if epsilon is 1/2, then the delta should change. So 1/2 means, let's say it's over here and here. So this is 1/2. So let's go ahead and find that on the graph right here. I don't know if I did that exact here. So now if I draw that down, now, so this is 1/2. The epsilon is 1/2. Okay, so here epsilon is 1/2. Then we see that this is a, which is 4. Now delta is 1. This is 1, which is the delta. Okay, so if epsilon is 1/2, then delta is 1. Now what we see here is delta depends on epsilon here, and then we can write delta as the function of epsilon, because if epsilon is 1, delta is 2. If epsilon is 1/2, delta is 1. This means that delta equals 2 times epsilon. Okay, so we can write delta as the function of epsilon. Okay, that was from the graph. So let's do this algebraically. So now it says, informally proving that limit as x approaches 1 of 5x plus 4 equals 9, that epsilon be greater than 0 be arbitrary number, then determine delta as a function of epsilon. So we are going to find delta as the function of epsilon, or we are going to write delta as the function of epsilon, so that if you give me some epsilon, every time you change the epsilon, okay, I can give you the value for delta. Okay, so this is how we are going to write this one. So here, this is the limit L. This is the function f of x. Okay, and then this is a. So we have a equals 1, f of x, the function is 5x plus 4, and the limit is 9. So the definition says for every number epsilon greater than 0, there exists a number delta greater than 0 such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is between 0 and delta. Okay, now let's see this. Let's put our information here. Okay, so f of x is 5x plus 4 minus L is 9. So that is f of x minus L is less than epsilon whenever x minus a is 1 here. So x minus 1 is less than delta. Now let's go ahead and simplify this. So we have 5x plus 4 minus 9. So this becomes 5x minus 5 is less than epsilon whenever x absolute value of x minus 1 is between 0 and delta. Now, if we factor out 5, then we get 5. Then absolute value of x minus 1 is less than epsilon whenever x minus a, the absolute value of x minus a, is between 0 and delta. Now, if we divide by 5 here, we get absolute value of x minus 1 is less than epsilon over 5 whenever the absolute value of x minus 1 is between 0 and delta. Now, what we see here is this inequality here is same as this inequality here. Okay, so x minus 1 is less than delta, and x minus 1 is less than epsilon over 5. So that means we can say this is delta. Okay, so this implies that delta equals epsilon over 5. So we can write delta as a function of epsilon over 5. So if we take epsilon equals 5, we get delta equals 1. If we take epsilon equals 1, we get delta equals 1/5, and so on. So the smaller the epsilon, the smaller the delta. The closer we get to L on the y-axis, okay, we get closer and closer to A on the x-axis. That's all this says, okay? Now let's look at another example. Now it says find the limit L and find the delta greater than 0 such that f of x minus L is less than epsilon whenever whenever that x minus a is between 0 and delta. Okay, so now first let's go ahead and evaluate this limit. We know how to evaluate this limit. Is a simple linear function, so we can do the direct substitution. So limit as x approaches 3 of 2x minus 4 equals, so we can do the substitution. So 3 times 2 is 6 minus 4 is 2. So the limit is 2. Now here L is this one. This is the function f of x, and this is a. Now by the precise definition, we can write for every epsilon greater than 0, there exists a number delta greater than 0 such that f of x minus L is less than epsilon whenever x minus a is less than delta and is greater than 0. Now here f of x is 2x minus 4, so we write 2x minus 4 minus L is 2, it's less than epsilon whenever x minus a is 3 here, less than delta. Now, if we simplify this, we get 2x minus 6. The absolute value of that quantity is less than epsilon whenever the absolute value of x minus 3 is in between 0 and delta. Now, if we factor out 2, we get x minus 3 is less than epsilon whenever x minus 3 is less than delta. Now, if we divide by 2, we get x minus 3 is less than epsilon over 2 whenever the absolute value of x minus 3 is between 0 and delta. Okay. Now, from here again, these two inequalities, they are same. So that means from here we can say delta equals epsilon over 2. Now, if you give me the value of epsilon, now I can find the value for delta. Now we are given the value of epsilon here, which is 0.01. So this means if epsilon is 0.01, then delta equals 0.01 divided by 2, which gives us delta equals 0.005. Okay, so yeah, so when we are given the epsilon, we are able to find delta. So that means this limit exists, and the limit is 2. So that's how we find epsilon and delta. When you move forward with advanced level of math, you'll do proving and a lot of things. But here we are just going to find epsilon and delta. That's all we are going to do. That's all for this video, and I'll see you again in the next video.